Hello, welcome to ASU. I know that we annually offer this type of lab tours for entering graduate students. Um, Unfortunately, this year we won't be able to do it in person. Instead, we take this video form. So it's exciting as itself because I never have done it before. My name is Shim, and I'm a geophysicist and mineral physicist. My specialty is to conduct high pressure experiment using a tool called diamond anvil cell. I'm particularly interested in interiors of Earth and other planets in the solar system and also extrasolar systems. So I'm going to give you a brief tour of my lab in this video. Thank you.
Earth's interior represents more than 99% of the planet's mass. It has a huge storage capacity for the elements that are important for the atmosphere and hydrosphere of the Earth's surface, and it has influenced the habitability of our planet. One of the most important aspects of the interior that I want to emphasize is the fact that the pressure impact is very large. The pressure at the center of the Earth is about 360 gigapascals. That is about 3.6 million times greater pressure than the atmospheric pressure. The tool that we use to generate such a high pressure is so-called diamond anvil cell that you're looking at now. It has a little diamond crystals, single crystal diamonds in there. They're natural stones, and you can see those white stuff glued to the metallic surface. The blue is epoxy glue that you're looking at, and it's got a very simple design of piston and cylinder. We phase those two anvils to each other, and then put the sample in between those anvils, and then squeeze them to a very high pressure. We have different style of diamond anvil cell. You can see the little one here with the four screws. It's amazing that this little tool can reach the very high pressure conditions of the Earth interior just by turning those four screws with Allen wrenches. By the way, the diameter of the cell is about 2 inches. Now, the typical size of the sample that we place in the diamond cell is extremely small. So we use stereo microscope that you can see now. There's a little diamond cell sitting there. Um, I'm gonna show you a culet phase of the diamond. You can think of a simple brilliant cut diamond stones that you can buy from gem store. We don't change the design a lot, except that we cut the tip of the diamond to make this flat circular shaped top where we locate our samples. For example, the QLED surface that you're looking at now is only about 200 microns in diameter. Your diameter of your hair is about 200 microns. So you can actually guess how small this is. And we cut a little minerals into a shape that is smaller than this cullet and then put on top of this cullet. Now, for beginners, it's very challenging to put this very tiny mineral grains on top of the anvil and kill it. And we use this robotic arm micro manipulator to move these little things to the top of the diamond anvil so that we can compress them to very high pressure. We also deal with other type of samples. In this video, you're looking at hydrogen gas loading system in my lab, where we inject compressed high density hydrogen gas into the sample chamber to understand hydrogen, which is a very important planetary material itself, and also interaction with silicates and metals at very high pressure. Um, we compress hydrogen to up to about 1,500 bars. That's fairly high pressure. And then we put samples and cell in that tank you just saw, and then we close the cell from the outside. Once we compress sample to the pressure conditions of the Earth and other planets, we also achieve very high temperature. The planetary interiors, the temperatures are really high. It's more than 2000s of a Kelvin, for example, for the Earth interior. So to be able to heat this type of temperature, we focus infrared laser beam through the diamond anvil and focus on the sample that allows us to reach temperatures higher than 2000, and the highest temperature that we can reach, for example, with the system that you're looking at here is about 6000 kelvins. For temperature measurements, we use black body radiation. Those white boxes show the spectrometer boxes that measures the black body radiation. Once we load the sample, we carry them to the synchrotron facility because the sample is too small to be able to measure with laboratory X-ray source. The synchrotron particle accelerator provides us with very bright X-ray beam that allows us to actually monitor chemical reactions and measure physical properties at in situ high pressure and high temperature conditions. Now we actually have expanded our research interest beyond Earth. Um, as you know, the InSight mission is measuring the seismicity of the Mars, and that probably lead us to gain more ideas about the interior of Mars and its past history. We also are interested in understanding a wide variety of planets that has been found by astronomers over many years, and we like to understand their internal structures, dynamics, and even evolutions, interactions between atmosphere and interior. So this slide shows some samples of the research area that we are currently interested in looking at. We study chemical heterogeneities in the Earth's deep interior. We're interested in understanding chemical interaction between the mantle and the core. Um, we we're interested in understanding how much volatiles can be stored in the Earth interior and influence the atmosphere and hydrosphere. Um, in astronomy, some exoplanets are believed to have large amount of water in it. We want to understand how water and rock interacts in those settings and how their geochemistry would be different from what we know from the Earth. We are also interested in understanding gas giants. So we have a interesting project going on for understanding a reaction between hydrogen and rock and hydrogen and metal. In this slide, I'm showing some sample research area that we have worked with graduate students in other field for their generals project. We had some graduate students who actually did high pressure experiment with us with large volume press available at ASU. We had some student project where we look at the planetary interiors and try to model the planetary interiors with minerals properties. Um, we also offer some project based on density functional theory calculations of materials at high pressure. So I wish this video captures our research activity, interest, and also our lab facility. And I hope you enjoy this video and have a great day. Thank you.